Okay. Assalamualaikum warahmatullahi wabarakatuh. Testing mic. 1, 2, 3. If you can hear me, just answer. Unmute your mic and answer it. Okay or not?
Can doctor.
If not,
Doctor.
type in the chat. Testing.
Can you doctor? Hello.
Testing. Hello. Hello.
We can hear you, Doctor.
Hello. Hello. No. Testing. Testing. Hello. Can you hear me?
Yeah.
All right. Okay, I can hear you. Wong okay. Sim Chong cakap no. Can you hear me? Testing mic. I think I need everybody to participate here. Okay. 1 or 2% or 3% to respond because to confirm the microphone is on and then both sides are okay. Right. Okay, good. All right. Assalamualaikum and a very good morning to all. So we are going to continue with week 2, which is the first lesson for week 2. So as usual, Sylvester is speaking. I cannot hear. Testing. Testing.
Can hear you, Doctor. Hello.
Speaker. Hello.
Hello. Doctor, can you hear me?
Hello.
Hello.
Okay. Tan Okay. Tan boleh dengar. Ada someone else. I'm not sure if the connection is a bit loose on the wire. So if for some reason during our class, if somebody asks question but I do not stop, then means that I cannot hear you guys. So I think someone need to start speaking. So because when students start speaking, I can actually see there's somebody speaking, but there's no reaction lah. Okay, so either way, you can just write down in the chat and also disturb me by trying to speak. Alright, so I think right now Tan boleh dengar
Yes, Doctor.
Boleh.
Boleh.
Okay. Alright,
Boleh.
thank you. Alright, so what Okay, we have roughly about 30 participants, so we start right now. So, Assalamualaikum, a very good morning. So, I hope that everybody is normal. Like I mentioned last week, before we start our class, no matter if it's in synchronous class or asynchronous class, make sure that you enter ULearn at the time of our class, 8 to 10 a.m. So in this week too, we are going to have the same learning outcome, is that you are going to learn about the concept of continuous time signal and the discrete time signal. And make sure that you tick on the attendance. This one is compulsory to be done by all students. So just tick on your attendance. Think just tick there and then attend. Just click there. You are attend. Okay, present. P is for present. And then, okay, I have actually given you guys an instruction for class. Okay, instruction is there for a reason, so that this class is a lot of mathematics, okay, calculation, 100% mathematics. Basically, theory is lesser, and because we are having open book and high order thinking skill question, so theory is actually will not be covered in your exam. Mostly will be on calculation, and the calculation won't be direct calculation. So our class will be consisting of 100% calculation. So that's why I ask all students to download and print your chapter 1 notes before classes. Reason why is that your notes, okay, your notes, the one I gave to you, so there are some empty spaces that you can jot down while I explain about the topic, or you can actually prepare additional notes paper at the side to jot down when we have exercises. So I have shared to you in Telegram on how to be a successful student. So normally for good student, I'm sure they are actually doing that thing. They were taking notes during class and so on. So for those who never did take notes during class, so you might start today, right? And for the online synchronous class is that, okay, this one, we will start on time. So we are going to start soon. So we have the activity and also class reflection. So I'm going to share my slide here. Okay, just a recap of what we actually done last week. For those who didn't attend, then you go back to the ULearn and go to the recording tab. So I have uploaded the link to the recording last week and go through the recording. So the students do not have excuses that they do not understand the topic, since you can actually go through again the class. But of course, attendance is considered did not attend. Okay. So to be considered that student attended the classes during the day of the class, they need to give a feedback on the class activity. So later on, towards the end of the class, I'm going to share to you some feedback on the comment by student. Okay, some actually did a very good job in terms of summarizing what they have learned for last week class. But some I think are a bit, I would say, lazy. Okay. Our class last week finished at 10. Okay. On time. But some student fill in the feedback form at 9:45, 9:30. I'm not sure why you actually fill that feedback form earlier than class. So when they summarize, it's actually, I would say, lazy lah, because what they summarize is that they say that they learn only for continuous time and discrete time. That's all. So it means that you just simply maybe open the WebEx, enter, and then go through ULearn and then submit the feedback form. So this type of student, please do not do that, repeat that again in this week session. So I'm going to go through. I will give you example of very good example of student giving feedback form, and example of not a very good, a poor example of feedback form. Okay, so that you know, do not do that again. So this is where you should it actually help you guys to summarize what you have learned for today for the class. Okay, so I'm going to continue for this week class. So what we learned last week was on the time shifting, time reversal, and time scaling. Okay. So this is all three is we call it as the time transformation. And what you have learned is, I gave you example was on the continuous time signal. So let's just go very fast on a recap on what you have learned last week. So we have the time shifting, and when we have the time shifting is that we have the original signal xt. Then when we have a shifting is that we have a minus t naught over here. So from t you have t minus t naught. Okay. And to know that whether it's a time delay or time advance is that by looking at the symbol, symbol here. Okay, so if it's plus symbol means that it's going to be time advance. So plus signal is time advance, and for minus signal will be time delay. All right, recap, very fast one. Since you guys I already explained to you last week. So this was the example of time shifting. So next is second one will be on the time reversal. So time reversal is that you have the original signal xt, okay, and t in bracket like this is for the continuous time signal, and for n here is for the discrete time signal. Okay. If you are blur, you don't know what I'm talking about, means that you didn't attend class last week. That's all. I'm not going to repeat. Go ahead and recut the recording. So how to do the time reversal is that by having the t value. Okay, original t value is only t, and for time reversal is to have minus t at the front of that t value. Okay, so similarly for the discrete time, so you have n here, so it will become minus n. Right? So what it means by time reversal is that whatever signal that you have here, original t, is going to be flip it. Okay, so it's going to be flipped, and you see that it's flipped at the t equal to 0 value. So this is what it means by time reversal. And if you see for the time shifting also, it's actually shifting with respect to the time axis. So time axis is going to shift left or shift right. So this is what it means by time transformation. Okay. Next, the last one that you have learned last week was on the time scaling. So time scaling is back again to the original signal. You have xt value, and for the discrete time you have n. So when we talk about time scaling is that you're going to have a value in front of the t. Okay, the domain there. So you have alpha n. So what is alpha? Alpha is a value lah, number. So the number can be less than 1, and the number can be more than 1. So if it's less than 1, it's going to be stretched, and if it's more than 1, it's going to be compressed. Okay, an easy example of time scaling is tape recorder. Okay, tape recorder or a video, a YouTube video. Lots of you guys, I think nowadays, you refer to YouTube video, right? So sometimes the person is talking very slowly. So you are waiting for them to finish up the topic. So what you want to do is sometimes you want to make the video faster, much more faster. So you might want to play 2 times speed. Okay, 2 times speed means that this 2 is the value of alpha here. So 2t, 2 times the speed. So what happens that if the video is 30 minutes long, okay, when you run it for 2 times speed means that it's going to be shortened, right? 15 minutes. So this is what it means. Means that if we have a value of alpha more than 1, which is this one, the signal will be compressed, will be shortened. Okay, so this is a very good example. You do not need to actually memorize this. You need to understand the concept. Okay, so these are the concept of time transformation. So what you have learned was the time transformation separately. Okay, now what we are going to do is that you are going to solve an equation with the combination of these 3 time transformation. So let's look at this example. Okay, this example, we have given xt. So xt is this signal. So you have a signal that looks like this, and you have it from the value 0 until 2, and you have with the amplitude of 1 here. Yeah? So find a, question A is x 3 over 2t plus 1. Okay. And another one is, by using the same signal, find the x minus t plus 1. Okay. So there are two ways or two methods to actually solve this equation, this equation of this signal using the time transformation. But before we go to this solution, so I want to get some feedback from student in the chat there. Okay, right in the chat for this question. Okay, what type of time transformation that you have? Okay, type that in the chat. What type of time transformation that you have? You guys, I'm waiting. In the chat, what type of time transformation do you have for this question? Okay, time shifting. Silver say time shifting. What else? The other? Are you sleeping? Okay, it's only 8 a.m. So the other student. Okay, Mama Haikal. Oh, Mama Haikal. Oh, you guys cannot answer to everyone. If possible, can you respond to everyone? If you cannot, then just to me privately. Okay. Maybe there's something wrong with the back recently. So anyway, you can just reply there. So Silver's answer, time shifting is correct. Haikal answer, you have time advance and time stretch. Okay, very detailed. Okay, very detailed, very good. Okay, time Tangzi, time shifting and scaling, time scaling. Okay, so you get the idea. Okay, so let's look at the example. Okay, so we are going to go one by one. So we have two different methods. Okay, I presume that in front of you right now, you have a piece of paper and a pen. So let's do this together. So we have x 3 over 2t plus 1. Okay, so you know that you can see directly in this one. Okay, if I were to write again this equation, so you have x alpha t, okay, sorry, alpha t plus 1. So you know that you have actually time shifting, you have time scaling. Okay, and you do not have time reversal, okay, because there's no minus in front of the t value. Okay, so we have only 2. So by using method 1 is that, okay, method 1 is that you're going to do time shifting first. Okay, method 1. And second, after doing the shifting, you are going to do the time scaling. So let's do the first one. Okay, so we have here, okay, time shifting. So time shifting. So what are the shifting value that you have? So if I were to take out the shifting value, so we have x t plus 1. Okay, so it's shifting, is it shifting advance or delay? In the chat, advance or delay? Advance, good. Muhammad Ridwan, So we have time advance. Why? Because we have this symbol plus. Okay. This one you need to go back and look at the recording last week if you cannot remember. So we have time advance. So if I were to actually, okay, draw it again. So this one is a tip for student. Whatever that I write here right now, to show to you how is the solution. This is what you should answer during exam. Do not skip, okay? Do not just simply skip because all of this have mark. So the drawing, even the symboling, and so on, okay? So draw out the time axis first, t. So you have 0, you have 1, 2, you have -1. Okay, let's say that is the value. So you're going to shift it by 1. So you're going to change the color, sorry. So we are going to shift this by 1 plus 1. Okay, so everything is going to be shifted. So we have here, so you're going to shift it like this. So this is the value of amplitude. Okay, so shifted by 1. So everything is going to be shifted. The original signal was here. Okay, so it was shifted to the left side by 1. Okay, that one is time shifting. Okay, done. Next is to do the time scaling. Okay, so time scaling is determine what is the scaling factor. Okay, so you have x just now. Okay, alpha t, right? So what is alpha here? So your alpha is your alpha is 3/2. So 3/2. So 3/2, the value is more than 1, right? So 3/2 is actually more than 1. So means that you know that it's going to be time stretch just now. Okay, it's like you run the video 3/2 times. Okay, the speed. So more than 1 means that it's going to be compressed. Okay, or shorten. All right. So by having that value, you know that alpha is 3/2. Okay, the easy way, this is a tips that I give to students normally, do not get confused, is you know that it's going to compress. So whatever t value here, you are going to actually compress it by a value of scaling factor. So because you know that it's going to compress, so you are going to multiply t by 2/3. Okay. Why? Very simple, because you know the scaling factor was 3/2, but you're going to, because you want to actually compress the signal, so you're going to multiply it, the reverse value for this alpha value. Okay, so whatever value that you have here, after you calculate just now, you're going to multiply it by 2/3. So if this is what -1, so you will get -2/3, 0, 2/3, and 4/3. So if you were to write out, you need to write it out, to draw it out. So we have t value. So if I were to follow what I have written up here, okay, so follow the blue colored font. So I have 0 here. I have -2/3. I have here 2/3, and this is 4/3. So the new signal is this value, okay, with the amplitude of 1. Looks the same? Yeah, it looks the same, but because I changed the value of t here, so this is also correct. Of course, you can actually draw it. If you want to represent it in a real value, then you can actually draw it compressed. Means that compress smaller like this. But don't get confused lah. Just multiply it by 2/3 here, and you will get the final answer here. Okay, very simple. This is method number 1. Okay. Any question before we go to method number 2? Any question? No? Okay, no question, then very good. Hopefully everybody understood about that. So now we go to method number 2. Reason why I teach you also method number 2, because previously when I teach student method number 1, some student, they want to use method number 2. So I also teach them method number 2 so that you don't get confused, because if you use method number 2 with the wrong procedure, then you won't get the same final answer here. Okay. So for method number 2 is that you're going to do time scaling first. Okay. And next is time shifting. Okay. So let's say let's give an example. If the question was you have also time reversal. So actually the next step here is after shifting scaling, you need to do the reversal, the last part. So if you have a reversal, then you need to go and do the time reversal, the last part. But since we don't have that, then we don't need to do that. Okay. But for the the method number 2 is that, okay, I just erase this because I want to give you an example of having a reversal. So pen. So if we have, for example, there are three time transformation for this equation example. So you are going to do time scaling first, and then you are going to do time reversal, and then you are going to do time shifting. Okay. Sorry, okay. Time shifting, But since we do not have any time reversal here, so we are going to omit that. Okay, so we are going to do only time scaling and shifting. So let's type out the original question. So we have x 3/2t plus 1. Okay, so the first method is that to do the scaling. But you know that there's a scaling factor here, 3/2t plus 1. Okay, so for scaling of this, you need to rearrange first the signal. Okay, so x, take out 3/2, the scaling factor, t plus 2/3. Okay, make sure that you left it with t here. Okay, this is the second method. If you are using the second method, which is you want to do the scaling first, so you need to make it left with only t value here, t value. Okay, this t value, Okay, so after you get this type of format, then only you can start to do the time scaling. Okay, so we start with the time scaling. Sorry about that. Okay, time scaling. So what is the scaling factor? You know that you have x 3/2 t lah. Okay, scaling. So draw out again t. We have here scaling by 3/2. So you have the original signal here. So I'm going to directly just jot it up here. So for method 2, you're going to multiply this original signal by 2/3 scaling factor. Okay, because you have the scaling factor 3/2, but because we want to directly use the signal, so I'm going every t value here, I'm going to multiply it by 2/3. Okay, why? Because 3/2, you know, is going to compress, so you're going to compress the value of t. Okay, so you will have here 0, 2/3, 4/3. So if you write that out, you have 0, 2/3, 4/3. This one you have minus 2/3. Okay, draw out that signal. Sorry. Okay, that's one. So these are the scaling factor, the first method, which is to scale it. So you get this one. Okay, so it looks like this. Whatever that you have here, multiply it by 2/3. Then you have 0, 2/3, 4/3. Okay, so this one will be the first step. Then you're going to do the time shifting. Okay, because we don't have the time reversal, then we are going to skip it. But assuming that we have time reversal, then you're going to do the time reversal first. So reversal is just to reverse it. okay, flip it at t equal to 0. Okay, but we don't have that, so we are going to directly do the time shifting. So time shifting based on this original value here, this one that we already format it again, reorganize it. So you have what value? The shifting xt plus 2 over 3. Okay, shifting by 2 plus 3 over 3. Shifting by 2 over 3. Okay, so meaning we are going to shift it, advance to the left side. So by 2 over 3. Okay, so this one is already very simple, shifting and 2. So you have the time axis here. Same thing, I'm going to copy whatever we have up here. Minus 2 over 3, 0, 2 over 3, 4 over 3. Okay? So we are going to shift that. Okay, shift it to the left side. So we have here, shift it by 2 over 3. Right. So this is the final, oh, sorry. Okay, this is the final answer. And if you see here, this one is equivalent. Okay, same, you get the same answer, left and right. Okay, at the same value and of t and the same amplitude. Okay, at 1. So this is the two method that you can use. Okay, but normally I will tell students the easiest way to not get confused, you need to do the scaling factor, because the difference between the two method is that you need to do an additional this additional step, which some students didn't do that. Okay, they directly do the scaling, here without do this process or step. So if you don't want to do this step, then use the method number 1. Okay, time shifting, scaling, and reversal. All right. So to look at look at your understanding here. Okay, let's look at do this. Save as. Okay, I give you a very okay, let's look do one more example here. Okay, for the question B, So question B, very simple. Let's do that. So what are the types of transformation that you have in this question? Answer it in the chat. Okay, Haikal answer time advance and time reversal. Okay, very good. So let's do this very fast. So I'm going to make it very fast. So we already know that there are two time transformation. We have time shifting, and then we have time reversal. Okay, so shifting method, very simple. The 0 minus 1, 1. Then we have 2. So shifting it by 1. So we have x e plus 1. Shifting. Okay, so it means that you're going to shift this to the left. So you have the okay, it's like this. And then the second one is time reversal. Okay, time reversal is that when you have minus t. Oh, sorry. The PowerPoint is not good when I've used digital pen. It's going to come out something like that. Okay, so you have x minus t. So you know you have a time reversal over here. Okay, so meaning that whatever the signal that you have done in the step number 1, you're going to flip it at t equal to 0. So you have t, you have 0. Oh, sorry, you have 0 over here. You have minus 1, 1, 2. Okay, so you are going to flip that. Okay, so the final answer is this. So for method number 2 is that you're going to do, instead of shifting first, you're going to do the reversal first. And then you're going to do the shifting. Okay, actually this question B is much more simpler than the first question A. So, but anyway, we just do this exercise. So for time reversal is that you're going to flip this directly, reverse it first. So you have 0, minus 1, 1, 2. And then you're going to, what's the signal? Okay. Oh, sorry. Wrong. Okay, so you're going to flip it at t equal to 0. So you have 0 here. So 0 means that it's going to flip like this. Okay, so you have minus 2 over here. So 1, 1 amplitude. Okay, so this one is for reversal. Okay, x minus t. And secondly, okay, because we don't have the scaling. If we have the scaling, then you need to do the scaling first. Okay, but since we don't have the scaling, then directly reversal. Okay, so for the reversal is that you're going to just reverse it, shifting it by x t plus 1. So shift it to the left side. Okay. Oh, sorry. I also did this same mistake like student. Okay. We are going to erase that. We need to do the formatting. This one is sometimes I also miss it. Okay, so sorry about that. Nobody actually mentioned anything, guys. Okay, so we have the original signal minus t plus 1. Okay, so what you need to do is that you need to take out the scaling factor right now, just now, kan? So actually, if you look at it, actually it's a scaling factor, but the scaling factor is actually equal to 1. And then you have the reversal because it's minus 1. Okay, so anyway, we just take out the scaling factor and the reversal. So you have minus 1, t, minus or plus? Minus 1, right? Why just now I noticed up until the shifting that it's wrong, because when I shift, it's not going to be the same solution to the method number 1 just now. Okay, so this one is the format that you are going to do when you are using method number 2. So you already have this. Okay, so first of next we go to the scaling or reversal. So anyway, because when we look at this, it's scaling by factor minus 1. So I'm not going to do scaling. I'm going to just do the time reversal directly. So time reversal. So you have x minus 1 or x minus 1t lah. Okay. So you have here 0, 1, 2, minus 1. Then minus 2. Right? So you're going to shift it, or sorry, reverse it at this value. So we do the same thing. So we are going to reverse it. We are going to okay. This is the time reversal. Okay, done. Next, we are going to do the time shifting. Okay, time reversal, time shifting. So time shifting, you have what value? T minus 1, x, t minus 1. So t minus 1 is it a delay or advance? It's a delay or advance? 0, 1, 2. minus 1, minus 2. Minus 1 is a delay. So if it is a delay, means that your signal will be shifted to the right side. Okay, so means that shifted by value of 1. So it's going to shifted by 1. Okay? So you have here 0. So shifted. So everything is shifted by 1. Right? So you see here that the answer is the same for method 1 and method 2. Right? If you didn't do this just now, where at the next step where I want to do the task shifting in the first version, so I noticed that shifting was advanced, so it's going to be wrong answer. So sometimes during exam, you can actually check if your answer is correct. If you have time, you can check by using the method number 1 and 2 to make comparison. If you get the same answer, then your answer should be correct. Right? So to actually see, to actually evaluate that student understood, so let's do this exercise. Okay. In Ulearn, I have updated the activity, the Padlet link in, I think, 2.3. 2.3. So click on that link. Do this exercise. Okay. Given xt, find yt equivalent to x1 minus t over 2. So the signal is given by this. Okay. So what I want you to do is that do this exercise. Okay. Method 1 and method 2. Okay. So how we are going to do this is, okay, this one I already open up. Go to the Ulearn class activity 2.3. Click on that and you will be directed to the Padlet. So in the Padlet here, okay, take 5 minutes lah. 5 minutes is enough, I think, to answer the exercise. Okay, do the steps that I explained just now, okay, using method 1 and 2. Okay, so let's do that using both method 1 and 2. And then after that, please upload your answer in here. Okay, when you upload, just click on this plus button. Write down your name. Example, your name is Abu. And then upload your answer. Okay, so that I know you're the one who are doing it. Okay, and on the PDF also, on top of the piece of paper, like what you do normally in your final exam, okay, you're going to write your name and matric ID and year. Okay, everything lah, your matric ID, so that I know you are from which year, from 2 BEKM or 4 BEKG or 2 BEKG. Yeah, so do that 5 minutes. I gave you until, we are now 4:44. So I gave you roughly about 5 minit macam kejap sangat. I give you up until 9 lah, 9. Okay? Including toilet break. 9 9 we come back again to discuss. Alright? Okay, all right. So let's look at what we have upload. Okay, so let's look at the bottom one, Chongja Kun. Okay, so okay, is in this direction. We just download that. Then I'll take another one. Ni anonymous ni siapa? Okay, I take this two. Job. Okay, before we go to the answer, so let's just do this very quickly, okay, so that everybody will have a go at it. Okay, so you have here the question. You look at the question, okay? So you have here the question. Question is, okay, given xt, find yt x1 minus t over 2. So what you need to do is that, okay, method one is that you either want to do the time shifting first, and then you scale it, and then you reverse it. Okay, so from this time transformation, you only have the, what do you have here? You have the time shifting, and then you have the scaling also, and then you have the reversal. So all three are there. Okay, so what you need to do is that first rearrange it. So you have y t equivalent to x minus t over 2 plus 1. Right? So we do first the time shifting. So time shifting. Hello, guys? You are there, right? So silent. You are there, right?
Ya,
Okay.
doktor. Ada, doktor.
Alright, ada. Saya macam cakap sorang-sorang. Okay. So, first we do the time shifting. Alright. So time shifting, what we have here is that x, okay, t plus 1. So it's very direct for the first method. So draw out the t value. Okay, you have 0, you have minus 1, 1, 2. So shifting by 1, so you know that it's going to be time advance. Okay, time advance. Okay, so shift it to the left. So you have left side. So you have here minus 2. Shifted to the left. Yeah, you should have something like this. Okay, with the amplitude 1 over here. Okay. Secondly, you're going to do the time scaling. So time scaling, okay, t. So time scaling is x scaling factor is 1 over 2, right? So 1 over 2 t. Okay. So we know that just now I mentioned to you guys. So it's very easy. Time scaling is multiplied by 1 over 2. So it means that you are going to actually compress it. So multiply it by 2. Okay, scaling factor 2 for the time value. So you can actually make it smaller, for example, but means that you want to plot it smaller, kan? But I don't want to do that method. I'm going to do the easier method. So times 2. So you have minus 4, minus 2, 0, 2, 4. So you have 0, 2, 4. minus 2, minus 4. So you're going to actually keeping the same shape. So it's easier for student compared to if you want to shrink it later on, because this one, okay, sorry, it's not shrinking, it's actually extending, okay. So this one is a scaling factor is 1/2, means that it's going to be expand. Okay, so that's why you see that the scale, the signal actually expanding from -2 to -4. Okay, from 2 to 4. So signal is expanding, right? The third step is to do the time reversal. Okay, so meaning that actually you have minus t here. Okay, this is very simple. Time reversal, actually you can do it together with time scaling, but for the sake of explaining, I'm going to actually show you here. So you're going to follow from the step number 2 here. So you have 0, 2, 4, minus 2, minus 4. So what you need to do is that you actually scale it. You multiply it by, if you want to take it as a multiply by -1. So meaning that what actually happened is that at this point is you actually multiply it -1. So what you have here is 4, 2, 0, minus 2, minus 4. Okay, meaning that, so everything here is actually the reverse of this second process. Okay, so if you were to do that, you get confused, kan? So anyway, just flip it at this point, t equal to 0. Okay, so you're going to flip that. So you have, let me eyeball that, 2, something like this, okay. So if you want to check, you can just check. At 4, you have this square. Okay, at -2, you have this type of signal. So this is at amplitude 1. So we have the final answer. Okay, so hopefully the student got the answer. So let's look at just now. You get the answer. Mana? This one. Let's look here. Let's look at the answer. So Chong Jia Kun, you did the time scaling. This is method 1. And then, okay, for Chong, he actually combined both. So you have the reflection and scaling factor. So you get the final answer. Okay, correct. Okay, method 2. Let's see the rest. Some student that just submitted. All Chinese student. What happened to the Malay student? Tak nampak pun Chan Rui. Okay, Muhammad Nukman. Okay, tengok Muhammad Nukman. Alah, hai kecilnya. Muhammad Nukman, when you take a photo of the exercise, don't take the photo of your keyboard. Crop lah sikit. Just directly on top of the paper. I cannot see basically. I cannot see. Okay. Take it smaller. Macam ni. Cropkan dia ke kan? Pun tak nampak juga. Mana? Oh, very small Ya, tengok yang ni lah. Okay, Yadi Yadi. So Yadi ni method 1 ke? Yadi method 1 ke ni? Scale. Tapi dia scale dulu. Ni method 2. Okay, anyway, you get the idea lah. Cannot. You just check that your answer is correct. So let's do method 2. Okay, for the first few weeks of the class, my pace is a bit slow, Slow because I want to cater for all students. Later on, when we go up to chapter 2 and 3, I'm going to have a faster pace, Okay, means that the scaling factor will be much more multiplied, Okay, speed. So, similarly to method 1, you're going to actually take out into the form of x, okay, and then you have minus t over 2 plus 1. So because first you have the minus t over 2, and because of method 2, you need to start with time scaling, and then reversal, and then shifting. Okay, so we take out this one, you have minus, sorry. You have minus 1 over 2 t minus 1. Okay, is that correct? Right? So from here is that you do the time scaling. First step. So time scaling is by x minus 1 over 2 t, right? So scaling factor, just eyeball it, multiply it by 2, kan? Because you have the scaling factor minus 1.2 means that, you know, 1.20 is going to be small. So you're going to make it compressed. Okay, so you're going to multiply by 2, but because, sorry, I'm going to remove that. Because we are going to look at the scaling factor, so we don't take out the minus reversal value, the minus value here. So only on the scaling factor. Okay, so, but of course, you can combine it if you are in advanced mode, but I'm going to teach it one by one. So you have 0, multiply by 2. So you have minus 2, 0, 2, 4. So you have minus 2, 0, 2, 4. Just draw the similar shape. Okay, so this one done for the time scaling. Okay, number 2, you go to time reversal. So time reversal is very simple. When you have minus, it's time reversal. So whatever that you have here, okay, in the second part here at t equal to 0, you reverse it. So I'm going to make it very fast. So you have t, you have 0, minus 2, 2, 4. Reverse it, swap it. So you have minus 4 here. Something like this, Okay? Is it correct? So you have something like this. Okay? So third one, this is time reversal. Third is you have time shifting. Okay, time shifting, look at here. What shifting do you have? You have t minus 1. Okay, so t minus 1 means that you're going to shift it, delay. So delay it by minus 1. Okay, shift it to the right side. So draw that again. 0. Let's see, because it's minus 1 kan. Okay, tak apalah. 2, 2, 4. Minus 2, minus 4. So everything is going to be shifted. So if you don't want to get confused, then just minus the time by minus 1. So you have minus 3, minus 1, minus, sorry, 1, minus 3, minus 1, and then you have 1, you have 3, okay? So you have roughly, this one is being shifted. Is this correct? Oh, did you see what I did wrong? Nobody actually mentioned anything. Is it wrong there? Nobody actually.
Yeah.
Nobody actually mentioned it. I was like, why is it shifted like that? Okay, so what I did wrong, okay, is, okay, you have here t plus 1, right? So and then I took out the factor minus 1 over 2. So this one should be t minus 2. Okay, so t minus 2, correct? So t minus 2, so everything is shifted by 2. So this one is much more easier lah for me. Okay, so shifted by 2. So you have something like this. Okay, so now it's correct. Just now, I know it's incorrect because it's not the same with method 1. So this one is method 1 and this one is method 2. Okay, so you get the same answer. Right, so hopefully everybody could understood what I explained just now. Okay, because next we are going to go to the amplitude scaling, reversal, and shifting. So if you remember, let me just take this. Okay, if you see here, so I'm not going to actually show it in a presentation slide because it's easier for me to actually and then write out there. So you have done on time shifting, time reversal, and time scaling, and also combination of all of it. Okay, just now. Now we are going to go to the amplitude shifting. So amplitude transformation. And for amplitude transformation, we have the similar transformation. Um, Similar to the time transformation. And so we have the amplitude shifting, we have the amplitude reversal, and then we have the scaling. Okay, so let's look at this example. Okay, so this example is when you have a signal xt given by this signal, and if you see here, example is that you have a block diagram. Okay, so here in the block diagram is that we introduce a gain factor and also a bias DC. So what is a gain factor? So you see here xt, yeah? So xt is actually represented by this signal. Okay, and then you have a gain factor 3. So the gain here is 3. Okay, and then you have a bias DC coming into the signal by -1. Okay, so if you were to in a exam, midterm exam or final exam, you're given this signal and this block. Okay, normally you should be able to write out the equation. Okay, the equation might not be given, this one, okay, and this one. Okay, so you need to know how to actually get the final equation, this equation. So how you do that is that by looking at the block diagram. So you have 3 is the gain factor, the amplitude, 3xt. Okay, and then you have the bias gain. So you have -3. So in the end, you have 3xt minus 1. Looks simple, yeah, but apparently when it comes to final exam or midterm, student they don't know how to derive this equation, apparently. Yeah. So this is why the reason I also teach how to derive it. So from here is that plot y. So y is what? Y is the output here lah. Plot yt equivalent to 3xt minus 1. Okay. In an exam, normally, normally in an exam, you are given this xt value. Sometimes this xt value, you will need to do the time transformation first. Okay, so means that if you have the time transformation and also the amplitude transformation, so amplitude transformation, when you have the value, the value outside of the xt value, and then minus t. So you know that you have this one is time transformation, and then you have here is amplitude transformation. Okay, so these are the two things that you need to, when you look at an equation, you need to determine that, oh, there are two types of transformation here. You have the time transformation and also the amplitude transformation. So which one you need to do first? Okay, the method is that you need to finish up the time transformation first. Okay, time transformation. And then only do the amplitude transformation. It's like mathematics lah. Settle it, whatever you have in this bracket first. And then only you continue with the amplitude transformation. Okay, and similarly to mathematics, when you look at this, you know that you need to settle out for this one first, 3x3, means that you need to do the scaling, the amplitude scaling first. So in contra to time transformation, okay, if you are using method 1, you need to do the time shifting first. Time shifting, time scaling, and time reversal. But in contra to the amplitude transformation, if you look at this equation, you are required to do the amplitude scaling first. So it's actually the opposite of the time transformation. So do the amplitude transformation, or if you have any amplitude reversal, then do that first. Then only you do the amplitude scaling. Amplitude shifting. So let's look at this example. So we are going to use the same exercise example. So we have xt, 3xt minus 1. So I'm going to draw that. We are going to do first. Okay, if you see here, you know that, oh, okay, we have the xt value. And then we have this 3 value and also minus 1. Okay, so which one is which? So this is amplitude scaling. And then this one is amplitude shifting. Okay, and I mentioned that if you are doing the amplitude transformation, you must start with the amplitude scaling first, and then amplitude reversal if you have one, then amplitude shifting. Okay, so these are the flow. Okay? And for this amplitude transformation, there is no method 1, method 2, only one method only. Okay, so first need to do amplitude scaling. So from there, okay, draw out what you have, 0, 1, 2, draw out the time axis first, minus 1. Then you have the amplitude scaling is by 3. So meaning that, okay, original signal you have the amplitude is 1. So what it means that the amplitude need to multiply by 3. Amplitude transformation is very simple. So multiply the amplitude by 3. So times 3. Okay, the amplitude. You multiply it by 3. So meaning that you will have the same, almost the same shape of signal. Just draw that. And then you have amplitude 3. So very simple. So this one is amplitude scaling. Then second one is that you have the amplitude shifting. So you have amplitude shifting. Don't forget to actually label everything. You have the time, you label the time. So amplitude shifting is that when you shift the signal, okay, if time transformation that is that you are going to actually evaluate it based on the time domain. Time axis. Okay, but for amplitude transformation is that you're going to evaluate it in respect to the amplitude axis. Okay, so means that whatever it's been done is going to be multiply the axis at the multiply times 3, or you're going to shift it up and down. Okay, that is what it means. Okay, so for this case is that you have time shifting minus 1, the shifting. So draw that, or if you want to make it easier, I make it easier for you guys. So whatever that you have here, amplitude is minus 1. So you have 3 minus 1, what do you get? You have what? 3 minus 1? 2 lah kan?
2.
0 minus 1? 0 minus 1, you get minus 1 lah kan? Minus 1. So based on that, you just eyeball it, okay? But make sure that the axis, x-axis is the correct axis lah. Okay, so you just put here 2 and minus 1. Okay, so what you need to do is that you need to draw it out. So just draw it out, very easy. Then minus 1 is going to be like this, and then this one is going to be dropped like this at minus 1. And then you have here another value. Oh, sorry, my drawing is bad. Okay, so it looks like this. This is at minus 1. Okay, so this one is how you should plot for the amplitude transformation. Okay, let's do this exercise. Okay, okay, this one, if you look at this exercise, it's the combination of time transformation. Oh, okay, lucky. Okay, I better save that first. Okay, okay. So you see here is that you learn about time transformation, and then you learn about the amplitude transformation. Okay, just now. Okay, so what I mentioned is that if you have both, you need to identify which one is which. Okay, so let's look at this. You are given xt. You are asked to plot for a y t equivalent to 3x 1 minus t over 2 minus 1. Okay, so which one is time transformation in this? Which one is time transformation? Because some students cannot identify which one is time transformation, which one is amplitude transformation. So which one, guys? If you have your mic, just answer it. Okay. Ada yang jawab. Sekejap, saya tengok dalam chat Alright, so Muhammad Ridwan ada jawab situ. Okay, Muhammad Ridwan dia jawab time transformation is x 1 minus t over 2. Okay, correct. So the time transformation is this one. This is time transformation. Okay, and the other two here, 3x and minus 1 is the amplitude transformation. Alright, so what you need to do is that you need to settle first the time transformation. So this example, x1 minus t over 2 is the same one that you did in the previous exercise. So where is it? This one again, x1 minus t over 2, right? So you have this, after doing all the transformation, either using method 1 or 2, you will get this answer. And then using this answer, okay, you're going to do the amplitude transformation. Okay, amplitude transformation. First, you're going to do the amplitude scaling, and then you are going to do the amplitude shifting. Okay, understood that?
Yes.
Okay, understood So, let's do this exercise. Okay, A and B. Okay, do it very quickly. I give you about maybe 10 minutes. Okay, because you have done this actually. And A and B is actually similar. Why? I think that's similar Kenapa saya type yang itu Sekejap I check my question. Okay, tak apalah. Yang B, the B question, if you see here, actually, T1 minus T over 2, and then another one is 1 minus 0.5 over T. It's the same thing. Okay, just that this one to show that there is another way in an exam to write out the equation. So it can be in minus T over 2 or given by minus 0.5 T. Okay, so let's do this very quickly. Okay, A and B. And I'm going to open this one in the Padlet. So make sure that you upload your answer in the Padlet. Okay. Okay, I gave it until 9:40. 9:45 lah because there are two questions But it's very simple 9:50 lah. 9:40. 9:40 Late? Okay. Hi. Okay. Okay, let me just share the slide. Have you uploaded? Okay. Alright. Chan Meng Chun. Okay. Fine. Example B. B. Okay, B. 2. This one. Where's the axis Siapa yang tanya? Nokman. Where's the x-axis? Sorry, the x-axis, the t. You didn't write out the t value Okay. Make sure that everything is labeled clearly Okay. So you have 4, 2. Okay, this one is good. Okay, this one A and B. This one apa? Un Yi Sui Okay, just let's go to and discuss very fast on this exercise. Okay, because we have only a few minutes left So like I mentioned just now, what you need to answer first is the time transformation here. Okay, so time transformation, I already taken it from the previous example. Okay, we have done the transformation. So this one is representing the time transformation x 1 minus 0.5 t. Wait, kejap What's the question? Question is, itu A. 3x Sorry, this one. So this one is the question. So you're going to answer this one. This is for A. Okay. So we have this one is based on x minus t over 2 plus 1. Okay, so you will get this transformation. And next is that what you need to do is that you need to do the amplitude transformation. So for amplitude, start with the scale first. And then next is the shifting. Okay, so start with the scaling first. So you have amplitude here is 1 original from the time transformation. Now we are going to scale the amplitude by 3. So actually what you have here is that this is amplitude is 1 multiplied by 3. So very simple. Just draw it out from the previously 2, 4. You have t here. And then you're going to draw out the similar wave Okay, and then you have the amplitude is 3. So this one is 3x t lah. Okay. Amplitude scaling. So next is the amplitude shifting. Okay, so you are shifting it by example, I'm taking it at a -1, so shifting it by 1. So like I said, when we talk about amplitude shifting or scaling, it's towards this axis, this axis. So we are talking about shifting it by 1. So shifting it by 1 means that you have the amplitude 3 minus 1, you get 2, 0 minus 1, you get minus 1. Okay, so draw that again, or I would prefer to draw it directly under so that you have the axis aligned. 0 to 4 t. So you're going to do the amplitude shifting. Draw that out. So you're going to shift it by 2. Okay, so you have example, this is 2, and then you have -1 just now. So shift that. Yeah. Okay, so you have something like this for the first example E. Okay, so this one is here. Okay, I draw it out here. So for this one is that you have the amplitude scaling. Okay, amplitude scaling, you have the scaling amplitude is -5. So meaning that this one is multiple by -5. So if you have this -5, then you have this is 0. Okay, very easily, if you understand the concept of amplitude transformation, then you know that this is going to flip down. Okay, you are actually doing amplitude scaling plus reversal at the same time. Okay, scale plus reversal. So you have 0, -2, -4, 2, 4. This one is from the original, is the same thing. So I'm going to just to do the amplitude scaling and reversal directly. Okay, so you have -5. So let's say that you have -5. I'm going to just plot it -5 over here. And then you have 0. Okay, everything is going to be flipped down. So let's see, 0 here. Then you have something like this. Right? So this one is for scaling and reversal. So next is that you have a time amplitude shifting. Okay, amplitude shifting plus 4. Sorry, plus 4. Okay, so meaning that your amplitude here is -5 just now, and so you just add all the amplitude with plus 4. So what do you get? You get here the amplitude is if I write here, this is -1, then you get that 4 is 4. Okay, so since I'm out of page here, so I'm going to redraw again on the right side here. So I have 0, -2, -4, 2, 4. You have the time axis over here. So you are going to draw it. You have a -1, this one, and then you have also 4. So -1 and 4. Okay, so draw that. Okay, so you have, if you want to draw it systematically, let's look at from the left to the right side. So start with the left side. So left side, and then you see at -2, you have the value is 4. So 4. And then you also have it at -1. The next at 0, you have it at -1. Okay. And then go next, it at 2, t equal to 2, you have at 4 and -1. So you have 4 and -1. Okay, and at 4 you have at this point. Okay, -1 and 4. So if you draw that out, okay, so it's going to be shifted. This is going to be shifted out. So sorry. Okay, so you will have the final answer like this. Okay, so did everybody got the answer? Did you get the answer? Guys? Okay, hopefully everybody got the answer. Okay, there's a question in the chat. Doctor, this is from Arina. Does the order of the shift, scale, and reverse for both time amplitude affect the answer of it? Affect the answer, or it does not matter? Okay, like I mentioned, okay, for time transformation, there are two methods, method 1 and 2. Method 1, you need to use the procedure that I gave you. Okay, method 1 is to do the time shifting, then time scaling, and time reversal. Method 2 is that you need to organize first the equation, then you can only go for time scaling, reversal, and shifting last. Okay. If you don't organize your signal for method 2, then you won't get the answer similar to method 1. So you know that your answer is wrong. So to be safe, I would suggest use method 1 only for time shifting, for time transformation. Okay. For the amplitude transformation, use the concept is simple like mathematics. It's like this example. Okay. In the center here, you have the time transformation. Then you know that you have here before x, everything that before x, if you have a value, then you know that that's a scaling factor there. or you have a reversal because you see that it's a negative. So you need to settle that, the amplitude and the scaling factor, and also the reversal first. Settle that, then only do for the shifting last. So that is the procedure. So maybe you can just do a very quick summary on each of that in the feedback form, because in the feedback form, I will ask students to do a feedback. So we are towards the end of the class. So go to you learn activity. Okay, activity, you actually done the activity just now. Right? So did I answer your question, Amira? Arina, Amira. Okay. Did I answer your question? Yes. Okay, that's good. All right. So for class reflection, go to the class reflection. So for this week class, okay. Okay, as usual, like last week, okay, what do you have you learned today? So let's say that I want you guys to do a summary of what you have learned today on time transformation, how many methods. So method 1 is how, method 2 is how, what is the procedure? And then you have the amplitude transformation. So what are the procedures? So just do a quick summary here. You can make it into a paragraph, it's okay. But just don't answer one sentence only. I learned about time transformation. Done. Okay. That one you can also know, you can actually go directly to my slide. You don't need to attend my class. So I would like to know that you understood about my class. So please write out a very good write up. Okay. And for today's class, do you understand about the topic? What do you like about class implementation? So this one is actually for my feedback. So I know, okay, this week maybe you say, oh, doctor, is very the pace is too slow for me. Maybe lah, I'm not sure. Some student is very fast for them. So I need to slow down the speed. So just write there what do you like about class implementation that you would like me to actually keep for the next class. So this one is a bit on for my own feedback so that I can improve for the next classes delivery. So for how do you rate me? Okay, 1 to 5. Okay, depend on you lah. Okay, terpulang you whatever. If you think that you can understood about the topic, then give 5 lah. If you say that so, then give 3 or 4. Okay. So would you like to maintain the same implementation like what I have done for last week and today? So just say there yes or no. If no, then you need to give some suggestion what you need. You think that I should give more implementation. Okay, so or if you say yes, also you can comment there. And anyway, okay, for your information and for class in the system, normally I will do the tutorial together with the class session. I'm not going to do it separately because to make students understand about the theory, the basic calculation and everything, they need to practice. So normally my class will actually combine with the tutorial like today. Okay, so I think that's all for today's class. So make sure that go through the feedback form. This feedback form, if you look at what I mentioned here, is that it is compulsory. Okay, each student is sorry. Okay, each student is compulsory to fill in the feedback form other than the attendance, and make sure that attendance, I saw that only 19 students only tick on attendance this morning. Okay, make sure that attendance is only will be taken only during class hours. So you need to click on your own. I'm not going to take it manually. You need to be responsible for your own learning. So click on that and tick present. Okay, as present. And to actually confirm that you really attended for the 2 hours class, then you need to be filling up the feedback form. Okay. And for your information, for all students, a reminder for you to sit for the final exam, attendance must be more than 80%. So I will look at the feedback form for the attendance. Okay, less than that, I will give a warning letter by week 6. Okay, so feedback form is only open until noon, but you have time right now, fill in right now, okay, so that you won't delay it. Okay, so any question before I end the class? Yes, siapa tu? Any question? Any question in the chat room? Tak ada pula. Tak ada. Madam in bracket. Oh, I just saw that. Apa ni? Kia Ziko. What the question ini apa ni? Madam in the bracket T-2. Oh, okay. This might be answer to my question just now. Okay. Jeffrey, Doctor, is only time transformation have two methods? Yes. I mentioned just now, for time transformation, there is two methods. You can either use the first method, which is do the time shifting and then only do the time scaling and time reversal. And then for method 2 is that you need to organize first the equation and then only you can do for the time scaling and reversal. Lastly is time shifting. Okay. Before this, let me explain to you guys. Before this, I only teach method 1. Okay. But some students, they would like to do the harder, the difficult method, difficult method, which is doing method number 2. They want to do a scaling first, but they scale it without reorganizing the equation, so they will get the wrong answer. So that is the reason why I'm teaching two different methods for time transformation. Okay, so you can either use, I would suggest use only method 1. It's much more easier. Yeah. All right. Any more question? Oh, and let me just share to you example not to do for the class reflection. Okay, this one is for the student who actually did. Okay, last week only 42 student attended out of, I think my student is already is about 60 student or 70 student. So make sure that for this week I would expect that full attendance or respond feedback form. Roughly about 70 students. So let's see the respondent that student answer. Okay, example like this. Sorry lah, but I'm going to show to you what not to do. Like Alif. Don't answer like this. The question was, describe what you have learned in week 1. And you just answer one sentence. I actually mentioned that at least 5-point form kan. Okay. So do not just answer this one. This one you don't come to my class. You can already answer this by looking at the PowerPoint slide. Okay. This doesn't show that you attend class. For example, a very good example is like Kuni Jun. So we look at him or her. I'm sorry, I'm not sure. But you look at how he explained very,
Madam?
very long. Yes.
Are you sharing your screen or?
Oh, sorry. Tak share. Okay. Thank you. Sorry, I tak share. Okay, I just repeat again. Okay, example in the feedback form week 1. Okay, Alif Azhan, don't do like this. The question was, describe what we have learned in week 1, which is last week. And you answer only this one. Okay, so don't do this. Okay, this is a very bad example of answering feedback form. What I expect is that at least minimum 5-point form. Okay, so this is a very good example from Kuni Jun. So he or she, I'm not sure. So he explain, until 8-point form and a very detailed. And I know that this detail is based on what I explained during the 2-hour class. Okay. So Chen Mang pun sama juga. No, don't do this. Okay. Okay. Explain much more thoroughly lah. Okay. So do some more extended summary. Take this as your own summary, what you understood about today's class. Okay. So I think that will be all. Any last question? No question? Okay, that's all. Let's see you guys tomorrow at 8 a.m. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you,
so
Doctor.
much, Doctor.
Okay, bye.
Thank you, Doctor.
Waalaikumsalam. Thank you, Doctor.
Thank you, Doctor.
Okay, bye.
Terima kasih, Doctor.
Sama.
Thank you, Doctor.
Okay, welcome.